Hey guys, the Network Berg here. MikroTik has done it. They've fixed one of the biggest issues I had with version 7 since its release, and that is using multi-protocol BGP with route reflectors. It's not even mentioned in the patch notes, but I've tested with 7.9 on its release candidate 4 build as well as the stable build, and it works on both releases. So I'm super excited. I'm very happy at this. So the only thing that MikroTik really still needs to fix to get me really happy with everything they've done is the BFD, but I'm sure that is coming pretty soon. So in this video, I'll just be setting up this multi-protocol BGP lab for layer 3 VPNs using a route reflector. I'll also be sharing the lab files that you can use with Eve. So look forward to that. So let's dive into the video. Alright, so this is going to be again another bit of a comprehensive lab. There's a lot of stuff that we will be doing. We will be configuring everything from scratch. From the IP addressing up until the MPLS configurations to the dynamic routing, and then finally we will set up that BGP peer relationship between a client as well as the route reflector. Now in this topology, provider 1 is going to act as the route reflector, with PE1 and PE2 being our provider edges, where we're typically going to be having these customer links come into or whatever services we want. You could extend this by adding additional PEs, it doesn't matter. The main focus is that we actually have this route reflector actually working correctly. Now, to start things off, I'm just going to clear this lab by wiping all of the configuration. So I'll just select all of these nodes, make sure we have a fresh setup here. If I can do this correctly, that would be great. So wipe the selected. And once the selected is wiped, I'm actually just going to go into the startup configs, because since I have added startup configs, if we start the devices up when I've shared this lab, you will obviously have everything just start up configured the same way that I already have, which is pretty nice if you just want to see the end result of what's happening. All right, so now that that's been done, let's start up our nodes. And this is all just MikroTik's running version 7.9. All right, now that the nodes have been started up, let's just quickly configure some of the stuff. So I'll log on to my provider 1 router, which is going to be our route reflector. So I'll just click on the node, open the link, have the pop-up, login admin blank, and then we should be able to just set our password. So I'm not going to look at the license, so let's just set the password. And there we go. Now we have one router that we can quickly configure. So I'm just going to run through the configuration relatively quickly. So what I'm going to do first is just set my identity to T1. We can then add our IP addresses to our interfaces. So primarily I'll be looking at Ether 1 and 2. So for this, I'll just add IP addresses on, well, the first address is going to be 10.0.0.1/30 on the interface Ether 1. And then I'm going to do the same for Ether 2, but this address is 10.0.1/30 for Ether 2. I'm also going to add a loopback address, which we will be using to be distributed via OSPF so that all of the peers can get to that IP address. And then we're also going to use that loopback address to connect using BGP. So let's add a new interface that will be, or let's add an interface bridge add. The name will just be allo0. And then let's add the loopback address of 192.0.0.0 or 01/32 to our allo0 interface. Cool. So now IP addressing is done. Next step is I actually just want to set up MAC telnet or sorry, Roman. So tool Roman set enabled yes, just so that we can easily access this device and all of the other devices using Winbox. And next step is I actually want to make sure that we have MPLS configured on the interfaces. So this is going to be also pretty straightforward. This is just MPLS LDP. We're going to add a new LDP instance, and we are going to set the transport address to the loopback address as well. And we're going to set our LSR ID also to the same address. And then we can add our interfaces for LDP. So MPLS, LDP, interface, add. Our interfaces will be Ether 1 and Ether 2. Cool. So MPLS portion is done. Next step is I'd actually like to add the OSPF so that we can dynamically learn routes from our neighbors. So let's just do a routing OSPF instance. I'll just add this, not add anything else. if I do a routing OSPF instance print, we should see that the router ID says main, but it should pick up that loopback address that we created. We can also manually set that. Maybe we should do that. So let's add a routing OSPF instance, set our router ID to 192.0.0.1 for line item 0. Next up is we'll do a routing OSPF, add an area, and our instance, or we're going to add, and then our instance will then be OSPF-instance-1. Since I didn't give the OSPF instance a name, it's just taken a default name, and that's what I'm tabbing to get that value. So let's hit enter. And now I can do the interface templates. So for this, I'll just do routing OSPF interface-template. I'll add a new template. And this template, let's just maybe maximize this a bit. We're going to add the interfaces as Ether1, Ether2, and Allo0. We're going to add our networks as 192.0.0.1/32, 10.0.0.0/30, as well as 10.0.1.0/30. So those are the network addresses for OSPF. And we also need to specify our area, which is going to be OSPF-area-1, which I also created with the basic default name. I can hit enter for this because that's all I need for the OSPF to function on this device. And let's just do the underlay or the basics first before we jump into the BGP. Let's just make sure that everything works the way we want it to. So we're quickly going to do the same type of setup on all of our other routers as well. So for this, I'm really just going to blaze through it. So I'm going to log on to my provider 2. If you do want some more context, I do suggest maybe watching my first video where this was just between two BGP peers, not using a router reflector since it wasn't working at the time. But now we can just quickly do everything in rapid succession to get everything working. So I'll do a interface or system identity, set name, P2. We'll add our IP addresses. And for this is, we have 10.0.0.2/30 for our Ether1. Our Ether2, let me just make sure what's connecting. Ether2 is going to our provider 3, and that has the IP of 10.0.2.1/30. And then we have a 10.99.255.0/30 address going to our provider edge. So let's just add that as well. So IP address 10.99.255.0/30, or not .0, .1, and that we can add to our Ether3. We want to add our loopback address quickly, so interface bridge add name allo0. Then we can add our IP address to the loopback address. So this is 192.0.0.2 to the allo0 interface. Now let's quickly add our MPLS config. So MPLS LDP add transport address will be the loopback address, and our LSR ID will also be the loopback address. Then we can quickly add our LDP interfaces. So here we can add Ether1, Ether2, and Ether3 because all three of these interfaces should be doing MPLS. And let's quickly add the OSPF. So this is just going to be routing, OSPF instance add, routing, OSPF area add with our instance being the new instance we just created. And then a routing OSPF interface-template will add. And for this interface template, we're going to do the same thing. Let's just add our instance as the one we just created, which was the OSPF, or not instance ID, I mean the area, that is OSPF-area-1. Then we can set our networks, which will be my loopback address. It will be my uplink to my provider 1. It will be the range between my provider 2 and 3, and it will now be also the link between my provider edge and my provider 2, which is 10.99.255.0/30. And let's just add our interfaces. So this is Ether1, Ether2, Ether3, and Allo0. And I think that should be it. Let's hit enter. Presto. So let's just quickly make sure that provider 2 is receiving, or that the OSPF is actually working, because we should be able to establish a neighbor with provider 1. So we can do a routing OSPF neighbors. Let's just print. and I can see that there is a neighbor that has been formed with my router 1. So I'm happy with that. And if I do IP route print, we should see that I am receiving some prefixes from provider 1. So that's awesome. The OSPF section is working. All right, let's jump onto provider 3 quickly. So same thing, and this is also going to be lightning speed. I don't want the video to be like 2 hours long. Should probably log in admin blank and then set my password. So quick succession: system identity set name P3, IP address. Let's add our IP addresses as 10.0.12/30 on interface ether1. Then we're going to have a 10.0.22/30 on ether2. And then we will have a 10.99.255.5. Would help if I didn't up that on ether3, because that is the subnet that's configured between my provider 3 and my PE2. So let's just add that. And next step is adding our bridge. So interface bridge, add name allo0, add an IP address to the bridge for our loopback. So this is 192.0.0.3 on loopback 0. Add the MPLS configs quickly. So MPLS LDP add LSR is 192.0.0.3, and our transport is the same. And let's quickly add the LDP interfaces. So LDP interface add interface equals ether1, ether2, ether3, because just like provider 2, all three of these interfaces will be participating in the MPLS connectivity in LDP in essence. Now let's quickly add the OSPF as well. So routing OSPF instance add, routing OSPF area add, and then use the instance we just created automatically, and then routing OSPF interface dash template. And then we can add this, set our area to the area we just created. And then we can add our interfaces, which is ether1, ether2, ether3, allo0, our networks, which is 10.0.10/30, 10.0.20/30, 10.99.255.4/30, and 192.0.0.3/32. Hit enter. Oh, and I forgot to enable ROM on my provider 2 as well. So let's just do a tool ROM set enabled. Yes, do that for provider 2 as well. But in essence, our 3 provider routers, our core routers, should now have OSPF and everything configured between each other. So let's just check on provider 1 if this is the case. So if I do IP route print, I see a bunch of OSPF routes. If I do a routing OSPF neighbor print, we can see I do have 2 neighbors with my other provider routers. And if I do an MPLS porting table print, I can see what this looks like. So this is pretty good. This excites me. This makes me happy. All right, now we can get onto our provider edges and do the same setup from there. So first thing I'm going to do is log on to the PE1. So PE1, pretty straightforward. Hit enter, and then admin blank no. Set a password. Let's just do a system identity set name as PE1. Let's do the ROM from the beginning. So tool ROM set enable yes, and then let's add our IP addresses. So IP address add address equals 10.99.255.2/30 on my ether1. And then I have a new IP address range, which is 172.29.29.1/29, which is going to my ether2, which is going down to my customer. And the next step, what I'd like to do is just also add my loopback address. So interface bridge add name allo0, and then add the IP address of 192.0.0.4 on the allo0 interface. So we've got that loopback address. Let's add the MPLS. So this is just going to be a case of MPLS LDP add. Our transport will be the loopback address, and our LSR will be the loopback address. And next step is our LDP interfaces. Which interfaces are we going to add here? It's kind of like a small little poll. If I look at the provider edge 1, how many interfaces do I need to add to LDP to make this type of solution work? If you guessed 1, you're correct, because I only need to add the interface that's going to be participating with the rest of the MPLS network. Ether 2, which is where the penultimate hop popping stuff is happening, you know, where it's like adding and removing the labels and stuff. We're not going to add that interface for the MPLS. So we just add one interface in this instance, which is Ether 1. And that should have this router now participating with the MPLS, but we need to make sure we add the OSPF as well. So I'm going to do routing, OSPF, and then we're just going to do a quick instance, add routing, OSPF area, add, set the instance to the one we just added, and then routing, OSPF, interface dash template, add with the area being the new area we just created. Our networks will be now 192.0.0.4, as well as the link between PE2 and provider 2, which was 10.99.255.0/30. It's just these two networks I'm adding, and then my interfaces will just be Ether 1 and LO0. I'll hit enter, and in theory, I should now also have neighborships forming between this and my other OSPF router, my provider 2. It hasn't formed yet, that's why we don't see any routes yet. If I just do a routing OSPF neighbor print, now we see there is a neighbor, there is adjacency, the state is full. So if I look at the routes now, I'm learning routes. Awesome. The main important thing for me here is to make sure that I'm able to reach the loopback address of the route reflector, which is this 192.0.0.1 address. So I'm just going to ping that. And I'm going to also just source that from my own loopback address, since that is what I'm going to be using as a local address when I configure BGP later on. So let's see if this works. It works, so perfect. And if I look at this forwarding table, it should be pretty basic. So MPLS forwarding table, if I print this, it's fairly straightforward since there's only the one interface where traffic is being pushed over, but it's fine. Don't stress too much about this. So this router has been done. Last step for this core network is we're going to go into this provider edge 2, open this link, and do the same setup here. So again, pretty straightforward. Set the password. Let's set our ID. So this is going to be our PE2. We're going to add our IP addresses as well, but let's do the tool, roll on, set, enable, yes. And then let's also do maybe a bridge already. So let's do an interface bridge, add name LO0. Let's add our IP addresses. So in this case, I know I'm going to add 10.99.255.6/30 because that is the IP between provider 3 and PE2. And that is on my Ether 1 interface. And then I have, again, another IP address between my provider edge 2 and my customer equipment. So that is going to be 172.29.29.9/29. That's on Ether 2. And then let's add our loopback address, and that is going to be 192.0.0.5 on LO0. Cool. Let's quickly add our MPLS config. So MPLS LDP, add our LSR is 192.0.0.5, and our transport is going to be the same. And then we'll do our LDP interfaces. So this is just, again, going to be Ether 1 because that's the only interface that's actually going into this core network. And then we can quickly add the OSPF as well. So routing, OSPF, instance, add. Routing, OSPF, area, add. And then our instance is the one we just added. And then routing, OSPF, interface, dash template, add. Our networks is going to be 10.99.255.0/30, as well as 192.0.0.5. Our interfaces is going to be Ether 1 and LO0. And our instance, or not instance, area is going to be the area we created. And if I hit enter, that should be it. So that should do the MPLS and OSPF section of the lab, we have this basic core network connectivity between all of our nodes in the ISP network. If I look at the routing OSPF neighbors, we're just waiting for this neighbor to come up now. Although I feel like maybe I forgot something, so let's just quickly have a look. IP neighbor print, IP address print. This all looks fine to me. So why is this neighbor not coming up? Let's quickly have a look on the provider 3 router as well. I just want to make sure that I've added this network. So let's jump onto Eve. And again, this is one of the wonderful things of not showing you guys all of the perfect scenarios. It's good if we run into issues because we can fix those issues. So let's just quickly check your IP address print. Can I actually ping my peer, which is .6? I can. So technically I've got this layer 3 connectivity. So why is this not working? Let's just look at the OSPF config here. So I've added this network, which is correct. I've added the interface. So this looks pretty good to me. But I still only have the 2 neighbors. Why is this failing? Let's see if we can pick anything up in our logs. So log print. Don't see anything strange here. But I'm not seeing anything on the Ether 3. It's just waiting for a connectivity. So what I might just do is just quickly force a connection. Most likely I've got something wrong on the PE2. Let's just go back to the PE2 router. And from PE2, routing OSPF export, let's just make sure I'm not missing any type of configuration. That's fine. Our area is fine. And our interface template looks fine as well. Ether 1 with the networks. Aha! I see the issue. I have the incorrect network address here. So let's just quickly fix that. So I can go routing OSPF interface dash template. Let's edit our networks. And then inside the networks, I'm just going to change this from 1099.255.0 to 1099.255.4. Save that. And let's see. Our neighborship comes up. How wild is that? It happens so frequently. If you just type quickly, how easy it is to make a little typo. This is why people love automation and stuff, because little mistakes like that doesn't really happen. All right, so now that we have this backbone network up, let's just quickly test. Can I actually get to my route reflector from this loopback address? I should be able to. I can, so I'm happy. All right, so the next few steps should be a bit more fun and straightforward, because we're just going to quickly configure the connectivity between my customer edges and my provider edges. Now there's one thing I actually still need to do on the provider edge, namely I need to create a VRF for this customer devices or for the customer network, since we want a separate VRF for their layer 3 VPN service. So I'll just jump onto the PE1 router. Let me just close all these windows, go into provider edge 1. And then on provider edge 1, all that I want to do for starters is go IP VRF. Then I'll add a new VRF. The name is going to be cust1 for customer 1. And our interfaces will be Ether 2, because I'm going to assign that actual interface that goes to the customer edge to this VRF. Typically, you maybe have this more in line with separate VLANs, and you'll assign the VLAN for a VRF. But I'm just doing this in this example using the physical interfaces. So I'll add Ether 2 as the customer VRF. And if I do an IP VRF print, we have that. But also if I do a routing table and I print this, you should see that it also creates a fib for the cust1 automatically. So you don't have to go into the routing tables and add that yourself. That's what's nice when you just add a VRF, it just automatically does that routing table for you as well. So it has a separate routing table. Awesome. Now, next step is let's configure connectivity to our customer edge. So for this, I actually also need to set up the customer edge, which is going to also just be another straightforward process. So I'll log on to this customer edge 1. I'll set a password for this device. Let's set this identity to CE1. Set name CE1. And then we can set our IP address to the Ether1 interface as 172.29.29.2/29 on Ether1. And then I also just want to add the address of 192.168.1.1/24 to Ether2 as our LAN network that the customer is going to be using. And these two LAN networks at the end of this lab will be able to communicate with each other over the MPLS network, which is going to be cool and sick, awesome, and I love it. So next step is I actually want the routing between my customer edge and my custom or my provider edge to also be dynamic. But for that, I'm also going to use BGP. I don't want to use OSPF in this instance. I'm actually going to be using eBGP. So this is why you see these different AS numbers here. AS 65100 is reserved for my customer edges, whereas 65000 is for my core network, my MPLS network, my network. So let's quickly jump into the configuration here. So from the customer edge router, all that I'm going to do firstly is create a filter or an address list for which routes we want to send out to our BGP peer. So for this, I'm going to do a IP firewall filter add, and we're going to give this a address list is what I want. And then we're going to add an address list. The list will be BGP out. These will be the prefixes I want to send out. And then my address in this instance is going to be 192.168.1.0/24. Cool. Next step is I'm going to configure my BGP connection to my provider edge. So I'll do a routing BGP connection add. My AS is going to be 65100. Let me just maximize this. My remote.as is going to be 65000. My remote.address is going to be the WAN IP of my provider edge 1, which is 172.29.29.1. Then my local.address, this is going to be, in my instance, my WAN IP, so 172.29.29.2. And my local.role. This is very important, and this is what usually catches people when it comes to BGP and MikroTik in version 7, is all of these different roles, because version 6 just kind of automatically figured out for you what role is what. But in essence, the main roles that you will be using when it comes to MikroTik will be eBGP, iBGP, and iBGP-RR. The rest is kind of like just there's ways and that they're supposed to be used, but it doesn't really work the way it's intended yet. So you'll mainly just be using eBGP, iBGP, and iBGP-RR. But we will be using this as an eBGP peer since we're connecting to another autonomous system number. All right. Now, other things that I can set here is maybe my output.networks, which is going to be that BGP-out address list that I created. And then other things I can set is maybe give it a name, very basic name, maybe 2-PE1. And anything else that I'd like to add here? Nothing specifically that I can see. I maybe just want to set the listen and connect to be set to yes. Yes, and then connect is yes. I will hit enter. And that is a magic BGP connection. So if I do a routing BGP connection export, this is basically what we added. We just set our peer to a provider edge 1, and now we can actually do the configuration on the provider edge 1 as well. So let me jump onto the provider edge 1 router, and then on provider edge 1, we're just going to do routing BGP connection add. Our AS is going to be 65000. And note, you can definitely ease this by doing stuff like BGP templates and ranges and stuff like that. I just like to be very granular when I set up these peers so that I have a single peer towards the thing that I'm actually connecting to, because I'm very much used to that. So AS 65000, or that is our AS. Our remote.as is 65100. Our remote.address is going to be the WAN IP 172.29.29.2. Our local.address is going to be 172.29.29.1. And you can kind of leave the local address blank. It will figure it out itself. Oh, I didn't set the loopback or the ID earlier, but it's fine. Not a train smash, we can fix that. It will dynamically choose a router ID if you don't specify one, but it's usually best to be very specific when it comes to stuff like router IDs. I should have done that with all of the OSPF peers as well, but I think you guys get the picture of how this configuration works. And again, that's why I recommend also watching the previous MPLS video where I do go more granular into this type of configuration. So let's add our local address. Let's add our local.role. This is also just going to be eBGP in this instance. And we are going to set our router ID this time, which is 172.29.29.1. Or I can make this the loopback address ID as well. That will not cause any issues. So this I can make 192.0.0.4. Remember, a router ID just needs to be something unique. It doesn't have to be something that's in essence routable. You can make it anything you want, just as long as it's something unique between the two peers and that it doesn't exist somewhere else. All right, so router ID is set. I'll set connect as yes. I'll set listen as yes. And I will set my name as 2-CE1. So that is fine. So what else do I actually need to add on my provider edge configuration? Well, since I'm using a VRF, I actually need to reference that VRF. So I will maybe set the routing table to the cust1 routing table, and I will specify the VRF as cust1. So it actually uses this VRF when it tries to connect. If you don't set the VRF and routing table, it's going to try and use the main routing table, and then the peer will just not come up. So let's quickly add this. You can add it. So technically, if I do a routing BGP session, I can print this and I can see there is a session that has come up. If I do an IP route print, I can see all of my routes here, but very important for me is the customer 2 route. So I can maybe do an IP route print where routing table equals cust1. And now we can see specifically all of the routes that we're learning for our customer 1. So I can see my connected route, which is configured on that Ether2. And I can also see my BGP peer has been formed with my CE1. So I am learning a route dynamically from my customer. So this is great news for us because this kind of means that we are almost done with the solution. We still just need to actually do the route reflector bit for the layer 3 VPNs to be spanned across the ISP network. But to finish this off, let's just quickly also add a BGP peer from provider edge 2 to customer edge 2. So it's going to be roughly the same setup quickly. I'm just going to log on to my PE2 and then I'll do a similar setup. So I'll just quickly do a IP route VRF or IP VRF add. The IP route VRF was the old way of doing it on version 6. My name will be cust1 again, and my interfaces will be Ether2. Perfect. Now let's quickly add our BGP peer. So this will just be a routing BGP connection, add. My AS is again going to be 65000. My remote.AS is 65100. My remote address is going to be the same. Well, not the same. It's going to be 172.29.29. I think this is 10 slash. I can just make it that. I don't need to add the slash. And then I'll do my remote.as. Oh, I've already done the remote AS, so I'm being really silly there. So let's just tab this. So we've got our AS, remote address. What else I need is also to just maybe set my local address. And this will be my actual IP here. So 172.29.29.9, which is the IP address of provider edge 2 on its Ether2 interface. And then I can set my local.role to eBGP. I can set my name as 2CE2. I'll do a connect yes. I'll do a listen yes. I will set my routing table as cust1, and I'll also set the VRF as cust1. Let's set our router ID. This I'll just make 192.0.0.5, which is the loopback address of this provider edge router. And if I tab this, is there anything else that I feel like I need to change or that I'm missing out? Nothing that I can see offhand. So we can technically just add this. and that should add our BGP peer for customer edge 2. So let's do the setup on the customer edge 2 router quickly. So if I open this up, give it a password, give it a name, CE2. Let's also just enable Roman on this. And let's give the IP addresses. So our IP addresses here is 172.29.29.10/29 on Ether 1. And also we will have the LAN subnet for the customer as 192.168.2.1/24 bound to Ether 2. And we can quickly do our BGP setup from here. So for this, all I'm doing is routing BGP connection, adding a new connection. My AS is 65100. My remote.as is 65000. My remote.address is 172.29.29.9. My router ID, this I'm going to make my WAN IP address in this instance since I don't have something like a loopback address on this router. So 172.29.29.10. Then I can do my local address, and that will be the same address, so 172.29.29.10. Think of this as the update source that I'm specifying. And then we can set our local role, eBGP. I'll set my connect as yes. I'll listen yes. Is there anything else that I'm missing? Oh, I haven't added the filter rule yet. So we can add this BGP connection. So if I add this, I can give it a name. So to PE2. So let's quickly add the address list as well. So I can do IP firewall address list, add name or list is BGP out. And my address in this instance is going to be 192.168.2.0/24, which is the LAN subnet of the customer. It's the range that I want to advertise out. So if I do a routing BGP connection print, I can now just add that value. So I can just do a routing BGP connection. Let's just use the set object or option, and then we can set our output.networks to BGP-out. And I know that this is line item 0 that I can see there. So I'll just set it there. And that's done. So if I do an IP route print, it's not coming up yet. Routing BGP session, let's print this. So I do see that I have a BGP session, but I'm not learning any routes because I'm not distributing anything out from the customer or the provider edge. So let's fix that because I actually want a default route to be pushed down to the clients from the peers. So I can just quickly go into both the provider edges. So I'll go to PE1, and then with the PE1 configuration, if I do routing BGP connection print, I can use the set command for default originate. Where is this option now? It is a default, so it's output.default-originate, and I can just set this to always, so it will always push out a default route to this client, and I'll just use this for line item 0. And it's going to be the same on the provider edge 2. So provider edge 2, routing BGP connection, set output.default-originate, always for line item 0. So with that done, actually, if I go onto the customer edges, so let's go to CE1. If I do an IP route print, I can actually see that I am receiving a default route from my peer. And it should be the same case for my CE2 IP route print. I am indeed receiving a default route from my peer. So in this topology, we now have a case where our provider edges are pushing default routes via BGP to our customer edges, and the customer edges are also advertising their local links or networks to our provider edges. So we're learning this route, but it's not being distributed across the ISP network yet because we haven't actually done the layer 3 VPN configuration yet. We've done all of the baseline things now. So if I go onto the CE2 and, for example, I try and ping 192.168.1.1, which is the IP address of CE1's LAN, and I try and source that from 192.168.2.1, what's going to happen? It's going to fail because I also made a small mistake here. I don't know how this happened because I could see it says could not. It's basically a socket error, and it's when you don't have the right IP address configured. And here I see I've got the wrong IP address set here. So let's just fix that up. So IP address set address 192.168.2.1/24 for line item 1. And now if I do that ping, it's still going to fail. It's just failing the right way now. Anyways, let's go back onto our topology and actually do the big thing that we're all here for, the layer 3 VPN connectivity. Now, one thing dawns on me, because I actually want to show you this configuration a little bit from Winbox as well, but since this is a new Linux machine or VM that I've brought up, I actually quickly just need to install stuff like wine. So let's quickly do that. I can do an apt get install wine. Let me just sudo this. And then once it has wine installed, and wine is actually quite beefy. I didn't know it was this big, but that's fine. It's one of those things. So let's install wine. And then while that installs, let's just go on to mikrotik.com, because many times you guys see me use stuff like Winbox on Linux, but you're not sure why or how I do this because it looks like black magic. It's just because of wine. So I can just navigate to the software tab. I can quickly download the latest version of Winbox. And once that's downloaded, it will be stored to my downloads folder on my actual machine. And I see wine's also been done. There we go, install completed. So what I can do now is I can just change to my downloads directory and I can just wine Winbox 64. This is just a first time thing. When you run wine for the first time, it does this. Afterwards, it's very quick when you start everything up. And there we go. Now I've got Winbox like any normal Windows machine. So let's go into my neighbors. I can see my provider 1, which is going to be our route reflector. So I'll do the route reflector BGP configuration via Winbox. And then the rest I'll still just do via the CLI, because I'm sure you can tell I kind of prefer CLI, but Winbox works fine as well. I actually love Winbox for certain things as well. So let's log on to our provider 1. And then with provider 1, let's maximize the screen, zoom in a little bit. And then while we're zoomed in, let's go into our routing, BGP. I can add connections. And this is where I'm going to be using iBGP connections. But since this is going to be a route reflector, I'm going to specify that this is a route reflector as well using the local role. So I can set my name. I can make this to maybe PE1. My AS is going to be 65000. My address families, now this is important. If you leave that blank, it will actually just use the IP address family. But since BGP is a multi-protocol, it can carry all of these different functions. It can carry IPv, IPv6, layer 2 VPN for stuff like VPLS or VXLAN, or it can do stuff like VPN 4, which is actually our layer 3 VPNs. So here I just want to make sure that since I am using VPN 4, I'm going to tick that as well. And then I can set stuff like my remote address. So here I'm going to use the loopback addresses that we did in the very beginning of the lab. So this is going to be 192.0.0.4 is PE1's loopback address. And the remote AS is going to be the same, 65000. My local address, I'm going to make this also my loopback address, 192.0.0.1. And my local role, if I click here, I can just set this to iBGP RR. I can set this for connect and listen. That just kind of forces it to participate in comms for BGP. And that should be it. I'm not going to add any filters or attributes or anything to this. This is just a very straightforward, very basic config. So I'll apply this. And let's add a connection for PE2 as well. So to PE2, 65000. Oh, I didn't set my router ID, did I? Let me just quickly also update that to the loopback address. And then I'll do the same for the second connection. So set our address family, so IP and VPN 4. Set my router ID to my loopback address. Set my remote address to the loopback address of PE2. Set the remote AS to the same, since this is technically iBGP still. Set my local address to my loopback address. And local role again is iBGP RR. I'll set it to connect and listen. And I'll apply this. So cool, we're done with the config on our route reflector. let's quickly jump to our provider edges. So for this, I'll just quickly do this via the command line again. So I'll go onto my PE1, and then from PE1, so the biggest thing that I want you to see when we are on PE1 is we're going to do a routing BGP connection. We'll add a new connection, and this is going to be, the name is going to be to RR. Our local address is going to be 192.0.0.4. Our local role, and this is what's going to confuse again most of the people, is if you're using this for the first time and you see that you made your route reflector, you set that to IBGP RR, it's kind of logical for people to think, okay, then I need to make the next one the IBGP RR client, because in your head that makes sense, but it doesn't work. You're going to not have any success. You need to set this local role to IBGP still. So you are forming an IBGP peer to the route reflector still, but you're not setting yourself as a client. And what I'm going to do now as well is just set my listen yes, connect yes, my address families. I need to set this for, I don't need to set it for IP since we're really just using this for the layer 3 VPN, but I am adding IP and I am adding VPN v4. And then my AS is going to be 65000. My remote AS is going to be 65000 because I'm making an IBGP connection. And we are going to do the remote address as the loopback address of the RR. Is there anything else that I need or want? Nothing that I see that's staring me in the eye, so to speak. So if I do a routing BGP session print, we can see it has established a session to the route reflector. So I'm very happy with that. That's perfect. That's what we want. We need to now just do the same thing on PE2. So let me navigate onto PE2. And then from PE2, again, very straightforward, routing, BGP, connection, add. We're adding a new connection. Name will be to RR. Our AS is 65000. Our remote.as is the same. Our remote address is the loopback address of router 1 or provider 1, the route reflector. Our local.address is going to be our loopback address. Our local.role is IBGP. We are going to set the address families for IP and IPv, no, not IPv6, VPN v4, and anything else. Connect, yes. Listen, yes. It looks all right to me as it stands, so I can just hit enter. And let's do a routing BGP session print. Perfect. So I do have a session between provider edge 2 and the route reflector. So the route reflector is connected to both provider edges. This is awesome. This is perfect. Let me just get back into Eve to kind of give you a visual representation of what's happening. But basically there's these tunnels being formed between these loopback addresses from route reflector to provider edges to kind of like learn and figure out all of the route information and such. And what makes this awesome now is the rest of the setup we just do on the provider edges. We don't need to go into the route reflector to add anything for the VPN4 configuration. Everything is now being done on the provider edges. So let me maybe just make sure that I can connect onto another provider edge using Winbox so that I can give you a clear representation of the configuration from Winbox side. I didn't want to connect to the provider router again. I wanted to connect onto Romon. And then from Romon, I should see a provider edge somewhere. All right, so I'll do this from provider edge 2 on Romon because somewhere I probably missed the Romon enable. So on PE2, to do the BGP VPN stuff, we'll go into our routing, BGP, and you'll see there is a nice little VPN tab. I can click on that. And then with the VPN tab, I can hit the plus. And now we have a route distinguisher. Now this is very important because a route distinguisher kind of is information that is sent via the MPLS network to label the stuff so that that information is stored somewhere. So this needs to be unique per customer and per VRF, I'd say. So in my case, I'm just going to make the route distinguisher 111:1. But you can kind of think of this as a 32-bit value that you can have 16 bits on either end. Some people tend to do something like make it their AS number. So let's say it's something like 64532 or whatever, colon, and then 1 for their first VRF or something. That's what people also tend to like to do. But I'm just going to keep it simple, 111:1. And then I can set the VRF to the customer 1 VRF. My label allocation policy is going to be per VRF because I'm going to push everything for this VRF. And then I can set my import and export route targets. Now this is very important because here we can import routes and export routes to MPLS using this label. This is why the route distinguisher is also important. And the other big important thing is here the redistribute. So this is kind of the routes that we want to advertise via VPN v4 or layer 3 VPN. So you can set this for the connected routes. And since I know that I'm connecting to my customer edges using BGP, I'm going to also advertise any BGP routes. So this again is, if you look at the routing table for that VRF, whatever type of routes exist that you want to push out over the MPLS network, this is where you can redistribute those routes. So I just want to push out connected and BGP. I'll hit apply and presto, I've done the layer 3 VPN setup on PE2. Let's do this on PE1. And I'm just going to navigate to PE1 quickly. So on PE1, very straightforward. We're doing a routing BGP VPN. Then we're adding a new one. We're going to give this, well, I don't really need to give it a name. What I'm going to do though is set my VRF as the customer 1. I'm going to set my route distinguisher as 111:1. I'm going to do my label allocation policy as per VRF. Let me just see, I don't feel like I'm connected here properly. Per VRF. I'm going to set my import route target, import.route-targets, and this is going to be 111:1, and my export.route targets is going to be the same in this instance. And anything else that I need, my redistribute. So this is export.redistribute, and this is where I'm going to be doing connected and BGP. I'll hit OK, and that should actually be it. That should be the magical thing that makes everything work. So I'm going to head on to Winbox to provider edge 2 quickly because I want to have a look and see if I look at that routing table, it's working. So I can actually see that I'm receiving this copied routes. That's what this Y is for. And it's actually receiving those routes via the provider edge 2. You can even see the provider edge 2 as the gateway address here, which is really, really cool. Now, the cool bit is if I also look at the routing table from the command line, so IP route print, where routing mark or routing table equals cust1, we can see that. But I want to show you what's happening with the MPLS as well. So if I do a MPLS forwarding table print, we can see that this cust1 exists here, and this is kind of where it's using that label, that 1111:1, to be advertised over the MPLS network and to pull and import and export routes is what I wanted to say, from within that VRF, which is really, really cool and really powerful. And this is all being done from the provider edges that's connecting with that BGP session to the route reflector to learn each other's routes and to get to each other. So now to actually test to see if the proof is in the pudding, so to speak, is I'll log on to the customer edge 1 and we'll just do a very basic ping test. So from customer edge 1, if I do a ping towards 192.168.2.1 and I source that from my own LAN address 192.168.1.1, what happens? Whoa. I know this looks a bit silly since I'm so happy to see this ping responding, but I can't tell you how happy I am to see this ping responding, because this means that the layer 3 VPN is working. These two sites are in essence connected to their own cloud. They can transfer data packets or they can get to each other. They just work, and it means that you can now properly deliver MPLS services using route reflectors with MikroTik RouterS version 7. For me, this is such a big, awesome change. I really am so happy and thankful that MikroTik fixed this. It's going to allow me to actually start planning to migrate my own version 6 devices that do make use of this type of configuration to version 7. And I know this seems like I'm maybe just rambling to myself, but I'm really just at a place of serenity now, because I can see so many different use cases for this and making everything a lot better for people that want to use RouterS version 7, especially if this was one of your bottlenecks. It's there, guys. It's really looking very good. Oh, I can't believe I'm freaking out over this. Anyways, what I'd like to say is this is it. This is the end of the lab. Again, I will share this lab file. You can import it into Eve NG yourselves as well. It's actually a pretty straightforward process to do. You'll just head on to Eve. There's a zip file that you can download from a Google Drive. And you literally just press this import button. You just import the zip file. One thing to take note of what that people tend to miss is there's another plus that you need to click, and then it starts importing. It will import that. One prerequisite though is you do need to have a RouterOS CHR version 7.9 installed on Eve already. Once you do, when you import the lab, I've already got the auto configuration running so that when you start the nodes, just wait a minute or two, and then everything will start up in this kind of state where everything just works. And you can kind of see how everything functions, how the configuration was done, and then you can potentially lab it yourself or build off of this as well. And I hope that this teaches you something and you learn something new, because this is really, really awesome. Stuff that I'd like to see from MikroTik next up is obviously the BFD, or maybe stuff like eVPN, which is also a pretty big thing. And I know that Kevin and the guys from MikroTik were talking about it, but I don't know how long that's going to take, since version 7 took it feels like 30 years to develop. I'm joking, obviously, but it took very long. So I don't know how long it's going to take to really bring stuff like eVPN to MikroTik. But this is a great start for me. This makes me happy, and I'll catch you guys in the next video. See ya.